Welcome back to my channel Maths Made Easy with AB. So students, we are continuing our series on play with graph. So this is, I think, the 11th video that we are making. So basically we have studied about, so I will write play with graph series, and in this series students we have seen how to draw straight line, how to draw parabola, ellipse, hyperbola, circles, and we have seen graphical transformations, how we can transform graphs. Say for example, fx is given a of fx. If you are transforming this to this, fx is given, what will be f of ax, and all such transformations we have seen. If you have not seen the videos on transformation students, I am linking the video and also providing it in the description. If you are first time in my channel watching my video, do watch those videos first and then you can come to this video. Again, this is the second part of the video of the booster series. This is basically application of graphs to solve mathematical problems that comes in JEE Mains and Advanced. Students, you need to be a master of graphs. If you don't master graphs, it will be very difficult for you to solve problems that come in JEE Advanced, at least. Yeah. So my motive here is, if you go through all the 9 videos initially, you will be able to solve any numericals. So I will be creating some of the important numericals that can be solved using graphs, and for that I am creating these series. So let's get started students. So the first question is, find the number of solutions of the question sin x is equal to log x base c to the power of x. Students, log x base c is also known as ln x, correct? Till class 10, if log x used to be given, you used to assume it as base 10. From class 11-12, if nothing is mentioned student, don't take log x as base 10, it should be log x base e, which is ln x also it is called. I think that is clear. In class 10, if only log x is given, the base will be log 10. In class 11-12, if log x is given, it should be base e. Yeah, I have already discussed in when we have seen the log graph which we had drawn in the play with graph series. Students, what is the meaning of finding number of solutions of any question? This is a frequently asked question, find the number of solution. Not this question as in I am saying find the number of solution. What do you mean by finding number of solutions? So basically you will have one function fx equal to another function gx. A function will be given, another function will be equated, and you will be asked find number of solutions. So how to do this problem? Generally you need to solve the equation or do it. Find how many values of x you are getting. Finding number of solution means x can get how many values, right? So how to do this? You need to, if fx is equal to gx, so you have to draw the graph of y is equal to fx, you have to draw the graph of y is equal to gx, and you will have to see at how many points fx cuts gx, or you can say gx cuts fx, or the graphs cut each other, correct? Find the number of solutions. Students, generally find number of solutions it's given. They are not asking you what is the solution. If the question is find number of solutions, be rest assured that you have to draw the graph, because solving and finding will be difficult. Okay, correct students, at normal conditions. Okay, so what you will have to do, fx is equal to gx is given, you will have to draw the graph of y is equal to fx, you will have to draw the graph of y is equal to gx. Say for example, y is equal to fx is like this. This is y is equal to fx. This is the x axis, this is the y axis. And y is equal to gx students, the graph, say for example, is something like this. This is y is equal to gx. The black one is y is equal to gx. The red one is y is equal to fx, and the black line is y is equal to gx. Students, at how many points these graphs cut each other? So 1, 2, 3. At 3 points, y, fx and gx cut each other, so the number of solution will be 3. So the number of solution will be 3. I am not solving this question. I have not yet solved this question. I am just giving you the technique how you will solve the question when they are asking you find the number of solutions. So basically you will have to draw the graph of y is equal to fx and y is equal to gx and see at how many points they cut each other. Now students, if I say you will have to draw the graph, then you should know how the graph is and how you should draw the graph, and for that check the 9 videos. So let's get started with the question that is given applying this. Students, I hope you are noting it down in your notebook as we go. You can pause the video or you can do whatever, you can take a note of it. Students, I think you are not just seeing this video like any normal video, you are noting it down as we go ahead. So maybe if in a 30 minutes video, you are spending a good amount of 1.5 hours and getting your notes ready, because that will help you revise in the examination. While you go for the final exam, do revise these questions. Students, now one thing I didn't say, fx is equal to gx is given, fx is equal to gx is given. Not necessarily always you can directly draw fx and gx. Not necessarily you can always directly draw fx and gx. Say for example, this question, fx is sin x and gx is log x to the power of x. So you know the graph of y is equal to sin x. I have already shown it to you earlier. But you don't know how to draw log x to the power of x. You know the graph of log x, but you don't know log x to the power of x. But if you do a simple funda over here, let me show it to you. A simple transition if you do, see over here, sin x is equal to, so you know the students, log a to the power of b. Can I write it as b log a? B comes to the front, b log a. This is a logarithmic principle and I think you know this basic. If you don't know, do revise logarithm. I will also create a video on log, yeah, and I will pin it later on. So basically this x can come in front and this will become log x base e. This x can come in front and this will become log x base e, x log x base e. Can I take x in the front? Can I take x in the bottom at the denominator? Now students, in the earlier video we had seen the graph of sin x by x. We had seen the graph of sin x with just the previous video, student. Part 1 of this video, we had seen the graph of y is equal to sin x by x. We know the graph of y is equal to log x base e. We will be drawing it simply at what points they cut each other. The question is now simple. So what is the graph of? Let me draw it over here. So this is the x axis, this is the y axis. What is sin x by x? Students, we had seen, so this point is 1 and the graph is somewhat like this. The graph is somewhat like this, students. We had seen this video. We had seen this graph in the previous video. The black color graph that you can see is the graph of sin x upon x. Clear, students? Sin x upon x. And this value is pi. This value is pi. Correct? You know the value 3 point something. Yeah. Now y is equal to log x base e. Y is equal to log x base e, students. It passes through point 1. So it will be somewhere like this and it goes till infinity. It goes till infinity. So this is the graph of y is equal to log x base e. So students, at how many points y is equal to log x base e cuts y is equal to sin x by x is only 1 point. 1 point is only 1 point. So the number of solution will be 1. So the number of solution for this question will be 1. This was a very simple question, student, but you saw how tricky it was. Yeah. If you are liking the video, students, do subscribe to my channel. Do like the video that you are seeing and share it in your circle. Also, students, if you have any doubt, you can go to the comment section and type it, or maybe if you have come across any question on finding number of solutions. Students, I hope you are solving test papers that you get. Maybe you have enrolled in some of the coaching institutions, yeah, and you are getting test series wherein you have got some doubt. You can go to the comment section and type that question. Maybe we all in my channel who are associated, we can solve it together. Yeah. So let's move to the next question. We will again see a question wherein you need to find the number of solutions. So let me write the question. Find the number of solution of mod cos x is equal to 2 box x. 2 box x. What is box x, students? Box x is nothing but greatest integer function. This is GIF, greatest integer functions. Already done it before. Yeah. Previous video also we had seen this graph and you already know that x is equal to this plus this. So x, a number, is equal to box x, the integer, greatest integer function, plus the fractional part of x. We have earlier seen the graph of y is equal to greatest integer function. We have seen the graph of fractional part of x. You have not seen this video, go back to the video. I will pin it also in the description section. You can watch the video. So you know this. So this is one important thing. Students, I'm just writing it down in case you have not seen this. This is an important formula, important concept. Okay, so you need to know this before going into this. So in calculus, we have been learning this. Do watch all my videos for more concept. Do note it down here. Maybe we are right now in this video, we will not go into this. Later on in some video, we will see this. So do write it down in case you miss out. Don't miss out on this, yeah. So let's remove this part right now. Students, the question now is, find the number of solutions. So basically, this part cuts this part. So you can do this. You can draw the graph of y is equal to mod cos x or and 2 of this, correct? But let me tell you one thing. So students, the question I will simply frame it as mod cos x upon 2 is equal to box x. Correct, for simplicity, as I told you. So basically, now the graph of y is equal to cos x. You know the graph of y is equal to cos x. So basically, you have 1 over here. This is the y-axis and this is the x-axis, students. So the graph is somewhat like this. Correct? The graph is somewhat like this. This is 0. This is pi by 2 and this is pi. This is minus pi by 2 minus pi and so on and so forth. What happens, students, if mod is given? So basically, the transformation is from fx to mod fx. The transformation is from fx till mod of fx. What happens in this transformation? The lower part is omitted and this part goes like this and this part goes like so. Lower part is omitted and all the part that was on the lower side of x-axis or the negative side of the axis, so basically negative y-axis, comes up. So this becomes the new graph. Let me make it all black line, else you will be thinking that this is the graph of y is equal to gx. Okay, so this is the graph, students, right? You got it right over here. So this is mod of cos x graph. Now students, you have to draw the graph of mod of cos x by 2. So basically what they are saying is, so let me now erase it for some time. You already saw the transformation of fx to mod of fx, correct? Lower part goes up. Now mod, so basically they are asking you in the transformation fx transform to a of fx. Fx transform to a of fx. What happens? What happens in this case? In this case, I am writing it stretch or contract. So it will be 1 by a, then whatever, yeah. Stretch or contract graph a times along y-axis. A times along y-axis. If fx is transformed to a of fx, stretch or contract the graph a times along the y-axis, which will be the case in this one. So it is by 2. So basically it will shrink, contract by 2 units. So you saw the range was 1, so that will become 1 by 2. You saw, no, the range was 1 over here. So this will become 1 by 2. It will contract along the y-axis, students. This transformation also we have seen earlier. Still, for revision sake, I am just telling it to you. What happens, students, what is the difference between fx transformed to a of fx? You saw what it will be, how it will be different if it is f of ax. If it is fx is transformed to f of ax internal, how will it? So basically that will be stretch or contract the graph a times along x-axis. So that stretch or contraction will happen along x-axis. But if a comes out, that stretch or contraction will happen along the y-axis. Very simple, already told before, just revising. So what will be the graph of mod of cos x by 2, students? It is now very simple to understand. This is the x-axis, this is the y-axis, and the range that was 1, the maximum part that was 1 is now plus 1 by 2, and this is your graph. oh sorry, this will not go down because it's mod also. So this is the graph, students, now. And this point is how much? This point is pi by 2. Pi by 2 minus pi by 2. Now students, you have been asked to draw. So this is the graph of fx, this part, cos x mod cos x by 2. What is, now you have to draw the graph of y is equal to box x. Y is equal to box x graph you will have to draw. Simple graph. Understand, box x graph you already know. This part is not included, correct? Students, you understand, you know the graph of y is equal to box x. Students, I hope till here it is very much clear to you all. I hope it is very much clear to you all, correct? Yeah. So now I'll use a different color pen over here. Y is equal to box x. So this is pi by 2. So 3.14 by 2 will be more than 1. This part is more than 1, no? Correct? And box x is somewhat like this till 1, correct? It is till 1. You know this. And then again at point 1, the graph comes into the picture. Again at point 1 the graphs come into the picture, correct? And so on and so forth, this side and this side and this side it will go, and that side it will keep on going, correct? Students, you can see that y is equal to y is equal to greatest integer function x won't cut this graph because it restricts here at 1, so it doesn't cut it. Now it is still half only, so the graph comes down like this. This graph is from 1, this is at 1, correct? So it goes up and up, so it will go up, and here it goes down and down. So basically the graph, this red line won't cut this black line, hence there will be no solution or zero solution. Basically the box x will never cut cos x mod of cos x by 2, hence it will have no solutions. Student, I think you understood this problem clearly, yeah, and hope you are enjoying the video. That I am showing it to you. Let me now move on to the next question, which has been asked before, and I will quickly go through that. I will not take much time. Find area bounded by, find the area bounded by y is equal to log x. Nothing is mentioned, so it is log x base c. Y is equal to mod log x. Y is equal to log of mod x, and y is equal to mod of log of mod x. This is the question. What is the area bounded by these 4 graphs? What is the area bounded by these 4 graphs, students? Pause the video for some time, think it on your own. So you know the transformation. So basically here 2 transformations will be required. This is a question that has been asked earlier in IIT, when IIT JEE Advanced used to be IIT JEE. You all know, must be knowing, yeah. So basically you know the transformation fx to mod fx. So it is just few minutes back we saw this in this video only. And you also know the transformation of fx is equal to, f of mod x. You know this also. Okay, so one is entire function mod and one is box x, this function mod. Students, if you don't know this transformation, I am linking it over there. Go to that video, see that, and then come back. Basically one side of the graph, this side of the graph you erase, and yeah, I'll not tell you, you need to go back to this video and then you need to solve this question, but I will give you the answer for this, students. I'll draw the graph. So basically the graph will be y is equal to log x, students, looks like this. I think you all know and you are then solving, you're just not memorizing the question. This is 1, correct? Correct, students? You understand this? What will happen if log is applied? This part will come like this. So this is one graph, correct? This is one graph. Another graph will be like this. Just a second. So basically one graph will go like this and one graph will be like this. So basically you are understanding that graphs are going always. So what will be the area bounded? So this will be the area bounded. This will be the area bounded. How did I do that? So y is equal to log x, students, this graph, y is equal to mod log x, this graph, log of mod x, and log of mod x again mod this graph. Correct? This side, correct students? I hope you are getting it. So this becomes the mirror image this side. Yeah. So this is the graph, students. So what is the answer for this? What is the area bounded by this? This area, this is 1 unit. This is 1 unit, already discussed before. I am not going into this again. Students, you are understanding, I am just skipping this part. This area 1 unit square, this area 1 unit square. So total answer is 4 unit square. So the area bounded by these curves will be 4 unit square, students. This is the answer for this question. Correct, students? I hope you got it over here. So for the students, basically I will not leave it like this, and I'll just explain it to you what is happening a bit, because I moved too fast on this. So for students, I think you got this part. Y is equal to log x graph is this. Yeah, this is x, this is y, and this is 1, 0. Correct? Students, correct? What happens with mod of log x? The lower part gets omitted, and this becomes the mirror image. Correct? So this is the graph. Correct, students? What happens to log of mod x? So what happens to log of mod x? So you have log x. This is log x. What happens to log of mod x? I had told you earlier that this side any graph exists? No, nothing exists. If anything would have existed this side, you need to omit that, and whatever is this side, you need to create a mirror image about y axis. So this becomes y is equal to log of mod x. Correct? This becomes y is equal to log of mod x, and mod of this again will become what? The mod of this part, this was lower, so basically this will go this side. So basically this region only exists. The answer is 4 for this. I hope, students, you got this. Yeah, I told you. So just for your understanding, I will repeat. If you forgot, fx to mod fx, the transformation is, if you have something like this, so basically this part will become the mirror image. The lower part will become the mirror image. This will become y is equal to mod of fx. And say if you have fx is equal to f of mox x, and if this is the graph, so basically you need to omit this side of the graph, and this side will become the mirror image. I hope this is looking like a mirror image. That's it. Yeah. Again, I am pinning the video. Do watch it. So now, students, let's get to the next question. I hope you are enjoying the video that is happening over here. Students, we will see one interesting graph. The question is fx is equal to x plus sine x. The question is fx is equal to x plus sine x. The question is, if fx is equal to x plus sine x, find integration 0 till pi f inverse x dx. F inverse x dx. Very important question. I think when I had given IIT in 2012, this question had come in a different way. Yeah, this question, although I had solved it, I think I faced some difficulty with solving this question. That had come in 2012 paper also. I don't clearly remember, but whatever. Let's proceed. Let me teach you this concept first. So fx is equal to x plus sine x, and you have to draw the graph of 0 to pi f of inverse x dx. Students, now first you have to know the graph of y is equal to x plus sine x. So this graph I am teaching it for the first time. I think in earlier videos I have not told you. This is x axis, this is y axis. Simply for fx is equal to x plus sine x, sine x graph you generally draw it on the x axis, which is somewhat like this. This is the graph of sine x, correct? This is the graph of sine x. This is correct. This is the graph of y is equal to sine x, correct? Now if the question is x plus sine x, this graph you need not draw it on the x axis, you will have to draw it on the line y is equal to x. So basically this is the line, y is equal to x. This is the line that you can see is y is equal to x, and the graph will be like this. The graph will be like this. So this is the graph of y is equal to x plus sin x, wherein this point over here is pi, this point over here is pi, 2 pi, so on and so forth. Correct? If this is pi, students, this will be pi also, because this is the line y is equal to x. This line, this part, this point I am saying, this part will be pi, and this part is 2 pi, so this part will also be 2 pi, because this is the line y is equal to x, wherein x and y both have the same value. Now students, the question becomes interesting over here. So this is the graph of y is equal to x plus sin x. Y is equal to x plus sin x graph. Now you have to find integration. So integration is nothing but area under the curve, but area of inverse of this function. Now students, see how interesting it is. How to draw inverse of a function? Inverse of a function is basically the mirror image. In the inverse function chapter, students, we have already learned it. Again, I am pinning that video. In the inverse, students, what happens is the graph just inverses along y is equal to x. So this, the red line that I have drawn is nothing. The red line that I have drawn is nothing but f inverse x graph of x plus sin x. This is the inverse graph of x plus sin x. And which area are they asking you to find? Simply this area, integration 0 till pi. This area they are asking you to find. They have asked you to find this area. They have asked you to find this area. Now see how simple this question is. Now see how simple this question is. How, students, this question will be simple? You know that this hump, the area is 2. Now this is symmetrical, so this hump also the area will be 2. So basically what I am saying is this hump is 2, so this hump is also 2. Correct? Correct? Now you can see this triangle. This is a triangle basically. Over here, this is a triangle. So how it is looking like? I'll just draw it for you. This is something like this, and you have a hump like this, whose area is 2. Whose area is 2. You need to find the area of this part. This is the triangle, right angle triangle, and this height is pi, and this is also pi. So students, what will be the answer? What will be the answer? So you know the area of the triangle is half into base is pi into height is pi. So half pi square. So basically pi square by 2 is the area of the entire triangle. Pi square by 2 minus 2 will give you the area of the shaded portion. Will give you the area of the shaded portion. So what will be the answer? The answer will be pi square by 2 minus 2. Pi square by 2 minus 2. That's it. Done. Such a difficult question. That's a difficult looking question solved in seconds, students, by graph. Understood? But only the main thing was you need to know this x plus sin x. You need to know this was the prerequisite. If you didn't know the graph of x plus sin x, you couldn't have solved the problem. But yeah, that's it. That's it, student. That's it. This is the answer. If x, you got the answer over here. I hope, students, you are enjoying this video. If you are liking the video, do subscribe to my channel. Yeah, I'll show you some similar graphs again. I think this is a very simple question. The hump is 2. Earlier we had seen this is the same hump. Students, sin x. Remember, this hump is 2. Cos x. This hump is 2. Half hump is 1. We had earlier discussed this several times. So that is the same hump, same area. Same hump and same area. That's it. Let's move on to the next important graph that I will show you. Just keep that graph also in mind. We had seen graph. We have seen sin x by x. We have seen this graph. We have seen just now x plus sin x. Let's now see the graph y is equal to x sin x. Let us now see the graph y is equal to x sin x. Let us now see the graph y is equal to x sin x, students. Now let me tell you, what is the graph y is equal to x sin? Is it the odd function or even function? So basically fx is equal to x sin x. What is f of minus x? So minus x into sine of minus x. Minus sine of minus is minus, sine of minus is plus, so x sine x. So basically this becomes equal to fx. So f of minus x is equal to fx. So basically students, this is an even function. This is an even function, correct? So it will be symmetrical about the y axis. It will be symmetrical about the y axis. So now let me draw it for you. This is the x axis, this is the y axis, students, correct? Just draw like this is the line y is equal to x, this is the line y is equal to minus x, this is the line y is equal to minus x, and the graph looks like this, and the graph looks like this. This is pi, this is pi, this part is 2 pi, 3 pi, so on and so forth, students. Say minus pi, minus 2 pi, minus 3 pi, minus 2 pi, minus 3 pi, so on and so forth. So students, this is the graph of y is equal to sin x. This part is symmetrical to this part. Since it is an even function, it is symmetrical about the y axis. Students, I think this is clear to you all, correct? Y is equal to sin x and x, y is equal to x of sin x. Got it, students? I think this concept, you keep it in mind. We will see some numericals further while we proceed. Yeah, understand, don't mess with 2 pi, pi and all. If I have written wrong somewhere, you correct me, because you know where x is pi, then what is sine, and so on and so forth. So you can correct it yourself if maybe somewhere it is a typo from my side. Students, circle, understand one important question before I end this video. I'll give you one important tip. So basically circle, the circle is a special ellipse, correct? Circle is a special ellipse where A is equal to B is equal to R. In ellipse you have what? You have something like this. This is A, major axis, minor axis, A, B, that is equal to R. So area of a circle, you know what? What is area of a circle? Area of a circle is what? Pi into R into R, correct? Pi into R into R. So if you have a circle, this is, say for example O, this is A and this is B, this is R, correct? This is A, this is B, correct? O, A, B, correct? This is A, this is B in case of ellipse. This is radius and this is major minor axis, yeah? So now you have pi into R, correct? For that, so pi into, can I write this as pi into OA into OB? Nothing but that. And what is the circumference of a circle, students? Circumference is 2 pi r. So can I write it as pi r plus pi r? Can I write it as pi r, pi r? Similarly, students, just r is replaced with a. The area of ellipse becomes what? Pi into OA into OB, or pi into AB, Similarly, circumference of ellipse becomes what, students? Pi A plus pi B, or pi common A plus B. That's the circumference of an ellipse, pi of A plus B. So similarly, I am comparing ellipse with a circle, and this is how it goes on. I think, students, you got this point, and we saw several numericals today. Students, if you have liked my video, if you have liked this video, do subscribe to my channel, do give us a thumbs up. If you have any doubt, anything you think needs to be discussed or I need to address it in my video, do write it in the comment section. Thank you so much for watching this video, students.